So it's my lucky day. Why? Because look at this beauty.
As you walk through, pretty much anything that you see in quantity is something that we make here in one way or another. These two machines actually make fittings. So like, for instance, this is a banjo fitting that's actually used in our air roll separator. But that machine, the machine behind me right here, actually makes this fitting. It takes about 1 minute and 37 seconds to make that fitting. It has an internally broached hex in it and a bunch of little passages and stuff. It's actually a little bit of a complex fitting. This also does AM fittings, so like your typical dash 8 ORB to dash 6 JIC, or you know, your dash 10 to dash 6. You know, this machine also makes all of those parts for us as well. Even our hoses get cut with a CNC machine. So you put a reel of hose basically on there. You tell the machine how many inches you want that hose to be. You know how many feet are on the reel itself.
Yeah.
And then you tell it, hey, I want 237 of these hoses. And it feeds, cuts, feeds, cuts, feeds, cuts. All it does is feed the cut hose all day long, normally. And then there's a CNC crimper on the other side, and same thing. That basically, you take the hose that you've done, the fittings that we've made. I can actually show you kind of some of that stuff. So I'll take a crimp collar that was made on the machines behind you, a banjo fitting that was made on one of our twin spindle lathes, and then this banjo fitting that you just saw that was made in the Swiss. And we'll basically take this, put it with this, the hose that's been cut on the CNC hose cutter, put them together, and then we put it inside of this crimper, and the crimper will crimp it. You know, and it's being crimped to a given size and for a given amount of time, and it's already calculated for spring back and all that kind of stuff. And the given amount of time basically holds it in place so that there isn't any it stays kind of with that memory. It doesn't kind of open back up. But even a process like that is controlled so that you don't end up with a hose assembly that has been crimped a little differently by one guy versus another guy. This is the engineering lab. Most of what we do in this room is reverse engineering. So you'll notice over here we have a ferro arm, which essentially can do a few different things. So we can use this basically to, if we have a given part, let's say I would put this part inside of this vise, clamp it down, and I can use this arm to either take a certain number of given points around the part with the end of the stylus, or I can scan it, 3D scan it basically with this blue light scanner. And so depending on what you're doing, if you're doing a simple part where you're just trying to pick up points, it's better to actually use the stylus. If you're doing something that has kind of a lot of organic shapes, it's very complex, then you use the scanner to basically scan it. And we use this in a given, in a fixed setting, like where you can actually have a part that is tightened down to a vise like this. We have a second ferro arm that we can actually roll out to a car. And same thing, if we need to pick up points on a car, we have a tripod that the ferro arm sits on and you can pick up points. And it's great for, like, if you're trying to pick up bolt locations, or just very detailed positions versus organic shapes. If you're actually working on something like, let's say, an oil pan, if I wanted to recreate this, or I wanted to bring this into a CAD software and change features about it or change the shape of it, it doesn't make sense to use a point probe to actually take points. You would actually want to scan it with a scanner. And this is an example of something I would put over there and scan with a ferro arm. Now, if I want to do that on a car, there's limitations with something like a ferro arm because you only have about a 6-foot swing, and you've got this big arm that you've got to kind of get into different areas. So if I wanted to get into, let's say, the interior and I wanted to scan a dashboard, the ferro arm isn't a very good tool for that, which is a handheld 3D scanner. This is an Artec Leo, and so I can take this inside of the car and actually do some scanning with it. The nice thing about it is this doesn't actually have to be tethered to a laptop. So I can take this inside of a car, I can take it under a car or in an engine bay, and I don't have to be looking at the computer while I'm scanning to see whether or not I actually picked up what I wanted.
Yeah.
The actual, whatever the scan is, actually will come right up on the screen, and I can see the quality of the scan, see if I missed an area, if I have to kind of come in at a different angle. But you can do all that kind of on the screen. I'll show you.
Dude, Wes will go crazy.
Yeah, that is so cool.
Wes is gonna be like, I need to order one of those right now.
They're fun toys. Actually, go into the scan, and I can kind of look at, how much of the door did I actually get. And you can see it actually even picks up the vinyl. Like this truck has a vinyl sticker on it, so it picked up even the vinyl decal on the truck. And then I can look at it different ways. If I want to look at it in full color, that's actually in full color.
Oh, wow.
So you see it's a bronze stripe.
Yeah.
Pretty awesome.
That's cool.
You got a little bit of junk there that we'll have to filter out, but
No.
in this case we were actually trying to scan for hinges on this side. Is really what that scan was, what we were trying to actually pick up. This is a tool we use in our process. It's called an XRF gun or an X-ray gun. And what it does is essentially it's taking an X-ray of metal to determine what the material actually is. So if you have a supplier, like we use a lot of raw materials here, so a lot of the components we make start from a raw material that comes from a mill that we have to either cut, grind, weld, bend, do some type of process to make a product that we're going to sell. And if we're selling somebody something, as an argument, let's say a step for a Bronco, and we're telling somebody it's a chromoly step, we have to make sure that the material we're actually using is truly chromoly. Or if we're doing a roll cage for a race car and we tell somebody, hey, this is Docal R6 or whatever, is it actually Docal? And so we use this gun to basically verify that the material that we buy is actually what the supplier says that it is. It's sort of a way to certify, the materials that we're using are actually what they're supposed to be.
And how often do you find that
All the time.
the material is inaccurate?
All the time.
And do you feel sometimes it's they're just trying to send you something to collect or sell it, or do you think it's an honest mistake?
In most cases, I would say it's an honest mistake, but it doesn't change that at the end of the day. I'll actually explain where this came from. So we had a part that we had ordered, that we manufacture here in the CNC department, that we had ordered 7075 aluminum. And material came in, we ran the entire production run of the part, which is about 300 pieces. We went through the other processes, we started selling the part, we started having a failure. And this is a part we had sold for a long time, and we had never had failures before, and it didn't make any sense. So the failed components came back, and it was still a small percentage. It was only about 2% of what we had sold that actually failed. But they started coming back, and we started kind of looking at it, and something just didn't look right. And it turns out, when we actually analyzed the part, or the raw material, it wasn't 7075, it was 6061, which is about half the strength of 7075. And so from now on, even if we had caught that at the end of the process, we would have spent all of the time to prep the material, 2 operations in the CNC machine, the time to deburr it, the time to clean it, send it out for anodizing. You're spending money obviously for anodizing, and then you discover the material's wrong. You've obviously spent a whole lot of money and a whole lot of time that you can't get back. And it may have been an honest mistake. The mill may have just grabbed the wrong material off the shelf, but they don't want to, it's very difficult to back bill for your time.
Yeah.
And just to attach amount of, value basically to the time that you spent on something.
Sure.
Yep.
It might be a part that I sell for $400. They're not going to give me $400 for it.
No.
And it's also your reputation. If that
Yeah,
part
it's
goes
a
out the door, you want the part to be right and not to have a problem, and be completely confident that it's gone through all those processes.
100%. Yeah. And at the end of the day, our responsibility is to the customer, not to the mill. So if something comes in and it's not what they say it is, I'm going to send it back, and they're going to keep sending material until we get the right stuff. We actually had a situation where a mill had sent it was supposed to be 1018 cold rolled steel, and we went to go bend it on the press brake, and it would crack. And check it. This is after we had bought the gun. I checked the material that was sitting here that had already broken, wasn't 1018 cold rolled, you know, so it can be an honest mistake, but it doesn't change that maybe that part I wouldn't have had to bend, and I may have done, you know, 500 parts and sold them under the assumption or under the guise that it was one material and really it was another. And that's not fair to the customer either. It's not fair to us, but it's not fair to the customer, you know, who's actually paying for the stuff. So from now on, every material that comes in gets checked with the XRF gun. It should just be regular carbon steel, but you basically pull the trigger and within a couple of seconds, you get your results. So this is A612 actually, steel, and then it'll break down the composition of that alloy.
Wow.
You know, there's that percentage of aluminum, that percentage of silicon, you know, chromium or copper, magnesium, you know, whatever's inside that, you know, whatever's this component's made of, will basically break down all of those elements, you know, on the gun. And then you'll notice if something is yellow, it's right on the edge of the tolerance that's allowed for that spec material. And if something's red, it actually is beyond the tolerance that's allowed. So Docal R8 is actually really is a really interesting one, because with Docal R8 there isn't a standard. You know, a lot of these other materials, if you're going to call a material 6061, there's a standard for what composition that 6061 should be. Docal R8 is a proprietary material that only one supplier has made specially and has formulated for them to sell. Well, we asked that supplier for a breakdown of what it should be and what the tolerances are. And when we check the Docal R8 here, it's often that we'll find that it's outside of those tolerances. And the supplier who sells it isn't the manufacturer who's making it, so they may not even know. But they're selling us something that they think is one thing, and the mill has run it and sold it to them, and the reality is it wasn't what it was supposed to be from the onset.
Wow.
And that could be in a roll cage that goes in a guy's car, that he wrecks at 230 miles an hour, and all of a sudden the cage cracks. You know what happens? Bad things happen. So it's
crazy.
From now on, we check everything. Here's an example of so we're working with a pivot manufacturer, a rocker manufacturer, doing some FA rockers, and we spec'd each of these different components to be different materials. And they got they got 2 of the 5 components right. And the other 3 components weren't what we spec'd. You know, fortunately enough, right now we're in the prototype stage. So we're not at the stage where we've actually bought anything to sell, but it's good to actually catch them before they actually do a production run.
Oh yeah.
So, you know, but you can actually, again, even something like this, I can scan. So you see this is 12L14.
Well, what do you want me to ask?
Blocks
I don't know where you want me to start.
What percentage of blocks are billet that you guys build versus the factory cast?
About 1%. And most of that is because it's cost prohibitive to do billet stuff. The cast blocks, after some of the value-added services, the modifications that we do, are strong and reliable up to, you know, the 900 wheel, 1,000 wheel range, you know, on a 4-cylinder, about 250 wheel horsepower per cylinder. You know, and the billet block might be good for 1,100 or 1,200, but the percentage of people that are trying to make that kind of power, you know, is a very small percentage of the people.
And earlier, JJ was showing us this insert here that they use to close deck a Subaru block, and he was mentioning how this specific scan gun lets them get the composition of the cast iron or cast aluminum block and be able to match the insert so it's as close to that same material as possible. So this, you know, prevents any issues from expansion and contraction, you know, when building the block or running the block.
So this machine and that machine and this machine are all used in the quality process, essentially in the CNC department. We use them for verification, so in-process verification. So we can have a part that we're running in the CNC department either in the middle of the process, so it might be an Op1 part that's been run on one side of it. We can bring it in here, we can actually put it in the scanner. Essentially, this scanner takes measurements all around the part, can measure bores, you know, threads, you know, the shape of the part, locations, and it basically you load to the computer, you're loading the actual CAD model of the part, and you load and you put the actual physical part that you've run in it, and it's doing a comparison between the part that you've machined and what the CAD model is. And it basically says, this is what you wanted, this is what you have. Where is there a deviation? Is there a difference? Are you out of tolerance on a certain area? And you can set the tolerance. Like I might say that part needs to be 1.1053 plus or minus 2, let's say. You know, and then it'll tell you, hey, this one's actually +4, or this is -5 here. And then you know that the part that came off the machine isn't what you really wanted. You can go back to the machine and make an adjustment. You know, so this is basically used for in-process quality control. That CMM is used for the same thing, and then this is what's called an optical comparator. It's basically a glorified microscope, essentially. You can put a part in here, and then you can take measurements. You can basically pick a point, pick another point, and take a measurement between those points to basically check things like size and locations and stuff like that.
Yeah.
You know, essentially.
Plan on doing upgraded DI?
Yeah.
Just a simpler, easy way to do,
That's not.
So this is about as basic as a CNC machine gets. This is a 3-axis vertical machine, which basically means that the spindle is in the vertical orientation and it moves in 3 different directions. The table basically slides forward and backward. The head itself moves left and right in the X, and then also moves up and down in the Z. You know, so this is about as basic as a CNC machine gets. This is a 3-axis, single pallet vertical machine. So and you'll notice that's actually not an extrusion. You'll see the material in some of the other areas of this department where it's actually extrusion.
Yeah.
Because it's a closed deck insert, it's actually a cast material. So this is a ground cast material.
Wow.
It looks like it's a billet or like it's an extrusion, but it's not. If I actually took a hammer across that part, smacked it, and broke it in half, you'd actually see it's a casting.
Wow.
So this is the machine that does our closed decking process in all of the EJ and the FA engines. And what essentially happens is we load these cast inserts that have already had an operation 1 done. We load them in the machine, and then we'll load a block on this turntable, on this rotary, and we'll actually do the closed deck process on the block to cut the known given size and shape, which is essentially our datum. Will get cut on the block here, and then the inserts will actually get cut down on the table at the same time. And the reason we do that is because temperature changes inside the shop. It's obviously very difficult to control the temperature here, as you know, versus inside of a climate-controlled room like the engine department. And because of that, we want to cut our inserts and cut our datum, our known given size, at the same time because those clearances are very, very tight. And so if it's 78 degrees in the shop that day, I know that my inserts got cut at 78 degrees and my block got cut at 78 degrees. You know, versus cutting the inserts, let's say today, and maybe 3 days later cutting the block. And then, you know, maybe the ambient temperature outside changed by 10 degrees. And now all of a sudden my sizes are completely different. So we actually cut inserts and block at the same time. So they've gone through the first stage, essentially, then they'll go on the machine that have the final.
Do you fill the inserts on their own, or they have to buy them in a box?
It requires machining. There isn't any good way
I didn't know, like, we saw like machine shops that may possibly use them.
Yeah, I mean, it's, you know, with closed decking a Subaru, it's a little bit complicated because there's a lot of different shape to it. So this is an open deck version, but there are semi closed deck versions that have little tabs that basically tie in the liners here. But essentially, this is what we're starting with. And then we'll put it in this machine and machine out a known given size and shape. And then after we've done that, we'll press the inserts in, and we do that through a process of shrinking. We use liquid nitrogen. You'll see there's actually, here's a liquid nitrogen doer.
That's cool.
We'll use liquid nitrogen to basically shrink the inserts, and then we'll heat the block up in a block oven, and we'll basically press the inserts into the block, and then as the inserts that are cold and the block that's hot all come back to normal temperature, it basically shrinks that insert in so it's a nice tight fit. But so we'll machine that for a known given size, and then we'll press inserts in, and then we do all the final machining in the same machine at the same time. So if you look kind of real carefully, you'll see that there's actually an insert there. There's an insert there, and another one here, and another one here, and another one here.
Wow.
Yeah, it's very faint, but yeah,
Wow,
I mean,
that's
comparing
very hard.
the one to the other, I mean, that's like night and day.
The two Haas machines that we have in the shop, one is basically dedicated just to doing the closed deck process, and the other Haas machine is dedicated to making one part of our aerial separator. So that Haas machine has only ever run one job its entire life. It's a 2019 machine, and it's only ever been on one job. You know, it's sort of the same thing with the VF4. That has only ever done the closed deck process. A lot of the other machines that are around the shop, the Akumas, are a lot more flexible. You can do a lot of other things in them, and they're a better quality machine. So the Centroid machine and all of our oil pump porting. So really all of this does is cylinder heads and oil pumps. So you'll put a cylinder head in. We've obviously already developed the program for these cylinder heads. So you'll put a factory cast cylinder head in, and basically the machine essentially does a few different stages of porting for that cylinder head, moves it around, moves in 5 different axes to port that you know, in a repeatable, consistent way every time. But if you were taking a cylinder head that you had not developed a port program for, the advantage of having this machine over, like, let's say a Haas machine to do that kind of work is the reverse engineering side of the machine. You can put a cylinder head in, you have a probe that you essentially load in the machine like this, and this company, Centroid, has written a macro to reverse engineer the shape of a port. So that probe will go in and touches off the side wall, move 100th out, touch off again, move, touch off, and do that over and over again, and then it basically lowers down and does the same thing. Lowers down and does the same thing, and it's basically creating splines through a port. Like if you imagine a spine in your back, how you have vertebrae, the machine basically takes a picture of the vertebrae, moves down to the next vertebrae, does the same thing, and the next, and the next, and the next, and then you basically take all of those vertebrae or all of those splines of the port, you take them into another CAD software, and you basically can change the shape in order to do what you've learned over time with flow bench that works, and basically change the shape of the port and then spit the information back to the machine and basically port that shape, you know, out of the material that's given there. So that's the advantage of having a machine like this versus a Haas machine where there is no good way to reverse engineer the port in a Haas machine. Very versatile, very flexible. It actually has a pallet system and a tombstone setup that has vices, basically four-sided vice, or a four-sided pallet, and then we have 2 vices per side of the pallet. So you have essentially 8 stations on one pallet and 8 stations on another pallet. The advantage of a machine like this with a pallet changer is your operator can actually be changing out the parts on this pallet while the machine is running the other pallet. Wow. So the machine never stops. Yep. So it runs 24 hours a day, 5.5 days a week. We actually run 3 shifts in the shop. We start on Sunday night at 10 p.m. and we run all the way until Friday at 10:30 p.m. essentially. And the machines don't stop running all week long. And then we have even more flexible machines like that one, which has a 12 but you can actually set up 12 different jobs, and we can load that machine on a Friday starting at about 6 o'clock. We'll load that machine up, and then when they leave here at 10 o'clock on Friday, they let that machine start eating, and it eats all weekend. They come back in on Sunday at 10 o'clock, and the machine's basically just finishing up, and they unload it, reload it again. Wow. So that machine basically will run.
So what did that machine cost? That looks expensive.
That's about a $1.2 million machine.
Ooh, sheesh!
I mean, there's a lot of different jobs. It makes sense.
That's a lot of Subarus, I'll tell you that right now.
That's not a Subaru.
I mean, that's awesome for you, because like at the same time, like your business doesn't shut down, but also your coworkers, your employees get to go home and stuff, and it's all automated. So, you know, it just the ball just keeps moving.
It's a balance, right? You
Yeah.
know, you're going to see a little bit later in our process. We actually have a robotic welder also, and we actually have a few robots for some of the lathes also. But you know, you can't. Robots are not going to replace humans. You're always going to still need a human to do the quality control checks, to load the machine, to program the machine. You know, to make sure that things are actually running accurately and smoothly. You know, the robots are really just going to kind of take the workload off of some of your staff, you know, and improve processes. Just like we had kind of talked about before, sometimes the robots do the jobs better than the people, but most of the time the people are going to do the jobs better than the robots are. So it just depends on the process, depends on the thing you're doing, but you're exactly right. The more you can have a machine run that doesn't require the user input, the better. Yeah, essentially lower. So this is a TGV housing, essentially, that replaces the lower section of an intake manifold on a Subaru. And these have obviously been ported or machined in a way that the port shape and size and the way that the port actually acts with air going through it is much better than stock. So there's a performance benefit. We pick up about 6 to 7 horsepower, wheel horsepower, basically, by just adding these, but still leaves the provisions for all of the factory butterflies and all the emissions components, so that we're not defeating any kind of emissions device, essentially. So this will be an emissions compliant part that still leaves all of the emissions components, but does that add a performance benefit. You set it up to do whatever those given jobs are. Like this one, we run 3 different jobs in. We'll run oil pans, we'll run air oil separators, and we'll run these TGV housings. And once it's set up, you don't touch it. And that's another sort of key, is the less time that you have to spend doing changeovers between jobs, the better. And we'll typically run a common production run size for us. A small production run is about 300 pieces. A large production run will be about 5,000 pieces. So, you know, when we set a job up to run, we'll run 5,000 pieces at a time, which might be 6 months worth, it might be a year's worth. It kind of depends on the part.
Yeah.
I'll say it because it's something that everybody in our industry has dealt with at some point or another. All of these different things happen from somebody pissing us off. You know,
We know that.
You have,
That's more motivation than
it really
usually
is,
than your
right?
own
So
self-motivation.
you have blocks. You send blocks to the machine shop. The machine shop tells you it's going to be $300 to hone these cylinders. It's going to take me 2 weeks, and I'm going to do a perfect job. You come back 2 weeks later, the block's not done. You come back 2 weeks after that, it's not done. You come back maybe a week later, maybe they started it. You come back 2 weeks later, maybe they finished it. Then you get it back to your shop. It's the shape of an hourglass. They didn't do a good job. You know, they told you because it took them more time, they had to charge you more money. You know, all of those things suck, you know, and they keep you from being able to do a good job for your customer. So a lot of these things happen because somebody upset us in some way or another, and we decided, hey, we just need to do this on our own. We need to take the stuff in-house, do it on our own, stop relying on other people. I can control quality, I can control lead times, I can control the price, and I know that the job that I'm giving my customer is actually a good quality job. You know, I don't have to worry about that I'm relying on somebody else to do one portion of it right, and maybe I do the other 99% right, but just like a clock, all it takes is one little chip and one cog, and the clock doesn't run time. It's the same thing with an engine. You know, you sub one process out and somebody screws up one process, and then it doesn't matter. The engine goes boom, and it falls, you know, it falls back on you. So we have a laser cutter that's over here that does sheet and tube laser cutting. So it cuts flat sheet and round tube, you know, basically with a laser. And in order to cut some of the thicker materials, you have to use nitrogen through the head and through, you know, that basically comes out with the laser in order to cut that material. And so we go through about one of these 12 packs, one 12 pack of nitrogen will burn up in about 2 hours of cutting. So you can see that's why we have a lot of 12 packs of nitrogen here, because we use it about every 2 hours. So in the past, we've had somebody bring our nitrogen in, and again, we're relying on somebody to supply us with nitrogen. We're actually in the process of putting a nitrogen generation system in. The system you'll see back here, it's still back because it's being installed, but we have dedicated air compressor. It's a special air compressor that actually basically pumps air over to this system here that generates nitrogen. Nitrogen is in the air that we're breathing every day. There's a small amount of nitrogen. So essentially the compressor is compressing the air to a high pressure. The nitrogen system is pulling the nitrogen out of that air, and then it basically goes through a series of filters and tanks, and then there'll be a booster that boosts the pressure up to 4,000 psi, which is what we need, and then that nitrogen will come out of the booster and get stored into these tanks. And then essentially out of these tanks, the nitrogen will come out of these tanks and go to the laser. So instead of relying on a supplier to supply us with 6 12-packs of nitrogen a day to just get through our day, we'll now be generating the nitrogen on our own and storing it in these 12-packs.
That's got to be a big savings.
Yeah.
It saves us about $5,000 a month.
Yeah.
Nitrogen.
Wow.
Well, how much does the equipment cost?
It's about a $170,000 investment in the equipment before the installation. But when you figure $5,000 a month, it doesn't take long to pay that $170,000.
The ROI is
Yeah,
fantastic.
exactly.
Yeah.
More importantly, all it takes is your nitrogen supplier to miss 1 day delivery, and
You're done.
that laser
You're
sits
out.
for 12 hours.
Yeah.
That's a whole lot of product we didn't make in that 12 hours.
Yeah.
It's not so much the savings of the nitrogen as it is the making sure that there isn't an opportunity cost that's lost.
It's not just
By
that.
the
I mean,
machine
also it allows you to be competitive and give customers a really good price on product if you're, watching your dollars. So
Now you have an endless flow.
So it's my lucky day. Why? Because look at this beauty.